Okay, welcome to this video on transformations. There are four types of transformation: translation, rotation, reflection, and enlargement. We're going to learn about how to use those four keywords and the information associated with them. Okay, now we have some old exam questions here, and in the first one we are asked to take this shape A and reflect it in the line x equals -1. Okay, so the first thing we're going to do is draw in the line of reflection, and it's a vertical line where it crosses the x-axis at -1 there. Okay, that's the line of reflection. Now the new shape is going to be the same distance away from that reflection line, but on the other side. Okay, so I'm looking at that and I'm noticing it's 2 squares away. So I go 2 squares the other side and I do a vertical line down there, and that becomes one side of the shape reflected. And then I just extend it across here by 2 squares and underneath as well, and then bring it to a point over here, roughly in the middle of those 2 squares, and goes from there to there, and that is the shape A reflected in the line x equals -1. Okay, in the next question I have a transformation already done, and I've got to describe fully the single transformation. Now it's really important when it says a single transformation, because what it means is you can't combine these. It's just got to be one of those four answers with its relevant information also added. Now this is a translation, okay? And it's a translation because what that does to the shape is it slides it along left or right and up or down by a certain amount, but it doesn't rotate it or change its size in any way, okay? Or flip it over. So the single transformation we need is called a translation. So we start with that word, okay, because that's part of our answer. And then we have to provide some important information that goes with it, okay? And the information we need to provide is some numbers to describe how far it's moved across and how far down. If I take, say, this top left corner, I can see I've got to go 1, 2, 3, 4, 5, 6 squares to the left and 1 square down. So it's a translation that's described by -6, -1. And we call this a column vector, okay, in a pair of long brackets like that. And it just basically means we move the shape 6 units to the left and 1 unit down. Had this been a movement to the right, it would have been 6. And had it been a movement up, it would have been 1. Okay, but the negative sign means left and that negative sign means down. Okay, so the next question is on the next page. This is a rotation 90 degrees clockwise, center naught. Quite a lot of information needed for a rotation. It's an angle, a direction, and a center of rotation. Now, just to help you understand this, you may have a piece of tracing paper with you in the exam to help you, but I'm just going to put a couple of lines on here and explain what they mean in a moment. That line is going from the center of rotation to one of the points on the shape. Now I'm going to take that line and rotate it to there clockwise 90 degrees. Okay, now those two yellow lines are 90 degrees from each other, and also they're the same length as each other, which tells me that that point there is going to end up here on the new shape. Okay, now if I took one more position on the shape, maybe if I do this in a different color, suppose I went from here to this point, then I notice that that's gone along 2.5 and up 1. So if I go instead along 1 and down 2.5 to here, that is where that point is going to move to. And the two red lines are also 90 degrees from each other, and they're both the same length. Okay, now with those 2 points there, that's more than enough for me to see where the shape is going to end up. So I don't need to add any more lines to the diagram, I just need to draw it. So this is going to become a vertical line down here. So that blue line I've just drawn there corresponds to this line here. Okay, and I can complete the rest of the shape just by counting the squares and filling in the gaps really. Okay, so it goes like this, and then there, and then there's going to be that piece across there, and then the 2 verticals there and there. Okay, and that is where the shape would end up, with a rotation of 90 degrees clockwise with the center 0, 0, sometimes just referred to as 0. Okay, now we go to the 4th question here, which is concerning a single transformation that maps A onto shape B. Now there's actually 2 possible answers you can give to this. The most likely answer would be a rotation, okay, and I'll just put a couple of lines in to show you how that would work. So if I took this point here to there, that's the nearest point, okay, joining the 2 shapes together, and let's take another one, maybe this one here, okay, down to this one here, its corresponding point on A, and you'll notice those 2 yellow lines cross at the point 0, 1. And that would be the center of rotation, because if I took any other point, let's say this one here, and took it across to its corresponding point over here, that would also go through the same point 0, 1. So it was a rotation, okay, and this is the most common answer that you would see for this question, rotation, okay, and this time it's 180 degrees, okay, rotation 180 degrees, and then I need to give the center of rotation center, okay, and the center is the point where those yellow lines cross through, which is the point 0, 1. All right, and that's the full answer. Now notice I haven't said clockwise or anti-clockwise, and that's because it doesn't matter if it's a 180 degree rotation. If it were 90 degrees, then I would need to say, as they've done here, clockwise or anti-clockwise as well. Okay, so that's my full answer to that. An alternative answer, okay, would be an enlargement. Now you might be thinking, well, it doesn't look any bigger or smaller than it was originally, but it is actually an enlargement, okay, of scale factor -1. Now I'll just explain that. Enlargement, scale factor -1, center as above, so the center is the point 0, 1. Okay, and what that means is that the shape A has been taken through this vanishing point, if you like, and out the other side, so it comes out upside down but the same size. That's why the scale factor is -1. Okay, both of those answers are acceptable and correct. Now we're asked to enlarge shape A by a scale factor of -0.5, center 0, -2. Okay, now first of all I'm going to mark the center, which is this point here. Okay, there, and I'm going to use different colored ray lines. I'm going to use red now, and so as not to clash with these. Now what I'm going to do is I'm going to take some points off of shape A and go through the centre of enlargement and out the other side. Okay, so I've gone through and I'm just going to carry on like that, deliberately further than I need to go. Okay, and I maybe take one more point. Let's take this one here. Okay, in fact the whole of the bottom of that shape, that's both of those points will come through this here and come out over here somewhere. Okay, and maybe we take this very far one here, okay, come down through here like this, okay, and continue it down like this. Okay, now what we have to do is consider that the new shape is half the size of the old one and upside down. Okay, it also means if it's half the size, it's going to be half the distance away from this center of enlargement. So you notice how this is 2 units away and this is 4 units away, right? That's 4 from the center and that's 2. The new shape is going to be 2 and 1. So in fact, its base here is going to end up between here and here. Okay, that's going to be the base of the new shape, and that's really all you need, because I can now see that this line here, which is currently a height of 2 up to this ray line, is going to come down to this point here, but only 1 unit away, like that. Okay. What else can we say? Well, this is 1 square across, but it's going to become half a square across when it gets down to here. Okay, so it's going to end up being like this point here, halfway through between here and here and down here. Okay, so that stops there, which is half a square between these two. And finally, I've got to just create the last bit, which I can see would go to there, and there, and there. Okay, because everything, I'll just do that last final line again, just so it looks a bit more horizontal. And that is actually the enlargement of that one, scale factor a half, negative a half, because it's upside down. All right, now with these it's better not to do too many of these ray lines and too many of the points. You can usually get away with just doing 2 points on the shape, and that's enough for you to recreate the new shape there. Okay, so it's not asked me to label it or anything, so I've drawn it there, and you can see it's half the size, upside down, hence scale factor negative 0.5. And the center of enlargement is the point there where all those red lines cross through. Okay, and that's an overview of all the transformations that you will need to know about for GCSE.